Say hello to my little friend. This is a Cisco router, but it's a sad day when a packet enters into a Cisco router and the Cisco router looks at the destination address and says, I don't know what to do. I can't forward it. That's so sad. So in our last video, we configured routers 1, 2, and 3 with basic IP addresses, and that's great because now they're directly connected to some networks and they have some routing information. However, they don't know how to reach anything outside of their directly connected networks. So in this 1-2 punch, in this video, we'll go ahead and do a strategic plan on what static routes we might add, make sure we understand how they work and make sense, and then we'll follow it up by an implementation video with a hands-on lab to actually implement these static routes that we plan for, and then also verify that they work. And I guess we could start off with the question of what do we want to be able to forward packets to? Maybe there's networks that we don't care about, and we don't need to waste time configuring a router to be able to forward packets to a certain network. But as a starting point, I know that we have a few networks. We have the 10.1.0 network, we have the 10.12.0 network, the 10.23.0 network, and the 192.168.1 network. In this topology, we're using a 24-bit mask across the board. If we want to take a look at what the router knows by default, we could go to the interface. In fact, let's do it. Let's go ahead and bring up router 1 for a moment. And on router 1, we can do show IP route and press enter. And router 1 says, I am directly connected to the 10.1.0 network. Yep. And also the 10.12.0 network. Yep. But outside of those two networks, it does not know how to forward packets anywhere else. So if we want, I mean, it's reasonable. If we want this router to be able to reach everything else inside of this topology, we could do it with static routes. And there's more than just one type of static routes, but I'd like to start off with network-based static routes, where we're training the router on how to reach a specific network. And we'll do some other videos with some default routes and host-based routes. But for this discussion for today, let's do our plan based on reaching networks. So we have 1, 2, 3, 4 networks. And having said that, let's go ahead and do a plan for R1 so it can reach all of them. So let's bring up R1. Let's put him right here. So this will represent the routing information that R1 is aware of. So R1. Now, we'll start with what he's directly connected to. He's connected to the 10.1.0 network off of this 0.0 interface. So we have 10.1.0.0/24. Great. And that is directly connected. Super. So in his routing table, it's going to show directly connected 10.1.0.0 as we just looked at. Let's verify that for a moment. And there it is right there. 10.1.0.0 is directly connected. Fantastic. Also, R1 is directly connected off of its 1/0 interface to the 10.12 network. So 10.12.0.0 is also reachable, and that is also directly connected. But what isn't reachable at the moment by R1 is network 10.23 and 192.168.1. So if we want to have R1 know how to get there, so let's add those with a static route. Now this is the planning stages, and then we'll implement it in the next video. So as far as planning goes, if we want R1 to know how to forward a packet to 10.23.0, we'll add that, 10.23.0. And now the question is, how? If R1 does get a packet that's destined for the 10.23 network, who should R1 forward that to? Now the answer to this is as straightforward as it might appear to some, and that is, if R1 wants to forward a packet to get to the 10.23 network, it's got to go to R2 in this topology. It's the only option. So what we could do is we could create an S, that's a code for a static route that says, hey, dear Mr. R1, to get to 10.23.0.0, go ahead and forward that packet to your good buddy R2. And one way of communicating that would be put the IP address of R2. So via 10.12.0.2 is the IP address of R2's 0/0 interface. So in the future, if we put the static route in, R1, if it gets a packet that needs to go to 10.23.0, it would say, I know what to do. I'm going to re-encapsulate this. I'm going to forward it at layer 2 over to R2, who owns this IP address of 10.12.0.2. Then R2 is going to de-encapsulate that, look at the IP destination, and say, oh, this packet's going to 10.23, etc. I'm going to forward it in that direction as well. And it can go ahead and continue the delivery. So now R1 knows about 3 networks, 10.10, 10.12.0, 10.23.0, but not this one, 192.168.1. So if we want to add a static route for that, we would. I'm going to ask for your help here in just a moment on how would R1 forward in the direction of this network. So if we create a static route for 192.168.1, 10.1.0. What would the next hop, who would the next device be in the path for R1 if it wanted to forward a packet in the direction of this network right here, 192.168.1? What would be the answer to that? And if you're saying, Keith, it's got to go to R2 again. In this topology, that's the only way to get there. And you'd be right. And so we could specify once again that the next hop that R1 should forward to, if he has a packet going to that 192.168.1 network, would be 10.12.0.2. And there we go. We've just included two static routes that gives router 1 knowledge about how to reach every single network in this topology anyway. The two that are directly connected and the two that are not directly connected via static routes. Fantastic. And these are network static routes, teaching the router how to reach those two specific networks. All right, let's play the same game for R2. So for R2, R2 is directly connected to a couple of networks. And I'd like to ask you, what networks does R2, by default, know how to reach once it has its IP addresses on interfaces that are up? And you might say, well, Keith, based on this topology, I get it. It's 10.12 and also 10.23 because it's directly connected to both of those. And you would be absolutely right. Spot on. So the only two that we need to add from R2's perspective is how do we get to 10.1 and how do we get to 192.168.1? So let's add those. These are connected here. Let's add the two additional routes as static routes. So static, let's go for 10.10 first. Okay, so from R2's perspective, if it needs to forward a packet to Bob the user at 10.1.0. something, who should be the next hop in the path for R2 to use? And the answer here is R1. And so because this is Ethernet, we'd want to put the IP address of that next hop, which would be R1's 10.12.0.1. So I'll put via here, 10.12.0.1. Perfect. All right, now R2, once that's configured, has a static route that says, I know how to forward packets based on if they're going to 10.1.0. The other network we have that R2 does not know about yet is 192.168.1. So let's solve that. We'll add a static route, 192.168.1.0 via, and you tell me, if R2 needs to forward a packet in the direction of this network, 192.168.1, who's the next hop going to be? Now, at this point, if you're thinking, wow, this could be R3, you'd be spot on. And more specifically, on R3, which interface would R2 use as the next hop? And the answer to that would be the interface right here that R2 can reach, which would be 10.23.0.3. So we'll put that as the next hop, 10.23.0.3. And with this configured, R2 now knows how to get to everything. Two networks it's directly connected to, and two networks that it has static routes for. And let's do the same thing for R3. And the repetition here is going to be good to reinforce this concept because it works the same way. R3 is connected to two networks, the 10.23.0 network, and also the 192.168.1 network, both with the 24-bit mask. So those are directly connected networks. And as far as the 10.12 and 10.1, we'd need to add static routes for that, or we could add static routes for that. So 10.12.0.0 and 10.1.0.0. Fantabulous. And now, I didn't leave myself quite enough room, but let me ask you a question. If R3 needed to reach the 10.12 network or the 10.1 network, needed to forward a packet in that direction, who would the next hop be? Who would the next device in that layer 3 path be? And if you're saying, Keith, it would be R2, specifically this interface 1/0 with the IP address of 10.23.0.2. You'd be right. So I'm going to just jot down there via R2, just like that. Now, I've done this before. In fact, I've done this probably thousands of times in both lab environments and also in production environments. And it never ceases to amaze me how even if we get the network, what we think is all set up and working, sometimes it doesn't work. Because there's two other pieces here that are critical to actually getting end-to-end connectivity between Bob and the server. And we'll just assume that we have the correct IP addresses and we're using IP addresses, so we're going to leave off DNS for a moment. But if this PC doesn't have the correct default gateway, so Bob should have his computer using a default gateway of 10.1.0.1. And that way Bob's computer knows to forward frames to the router in the event Bob's computer is trying to reach any network other than his local 10.1.0 network. The other half of this is the server. The server in this case, if it's on the 192.168.1 network, it needs to use a default gateway of R3, which is 192.168.1.3. So everybody has to cooperate. Everybody has to have an idea of who to forward it to so that packet can be forwarded in the direction of the final target or final destination. One other aspect in this planning that we also want to consider is that sometimes PCs have firewalls. So if you have a PC and a fairly current PC operating system like Windows 10 or whatever, there's firewalls that are on by default in many cases. So if the server over here or a router tried to ping a PC and it has a personal firewall on it, the PC may not respond. So just be aware of that also as a possible consideration of why a computer may not be pingable. It may be the operating system that is simply not allowing that response. So that, my friend, is just the planning stage for getting network-based static routes implemented in our little topology. So in the very next video, we'll take this plan and we'll implement it, which will give us hands-on practice in both implementing the static routes, walking through the syntax so you get comfortable with it, and also verifying those routes once we put them in, and also verifying end-to-end connectivity. All of that is in the very next video, so I'll see you there in just a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.